Hi, fourth grade. So for today's math lesson, we are building on what we learned yesterday about composing and decomposing our quadrilaterals. And we're now composing and looking at the triangles that we use to make different quadrilaterals and kind of building a bridge between creating our own quadrilaterals based on triangles and using triangles given, looking at the side lengths and our angle measures to determine what kind of quadrilateral we can get. So if we look at number 10, okay, 10 through 15, we're taking the angle measures that, froze in here. We're taking the angle measures that were given, right? And we want to look at attributes that are in the angle measures of our quadrilateral and of our triangles and determine what, what shape we're making here. So I'll figure out why I'm still frozen. Let's try this. Try and get it connected again. There we go. Okay. So if we look at triangle V, that's the only triangle with a right angle. So we can look down at our quadrilaterals in 10 through 15 and look to see which one has a right angle. And right away we see number 10 has that right angle, okay? And there's several, okay? So we're just going to look at how they have drawn that diagonal for us to create those triangles. And we're looking at two right triangles here. So we're going to just decide what kind of triangles are given based on either the angle measure or the side lengths. And I would encourage you to look at the angle measures first and then look at side lengths. So looking at our angle measures here, we're given right triangles, and I'm just going to use our triangle symbol to shorten it. Okay, and then we look at what kind of quadrilateral we formed. And we have a rectangle, right, because there's two pairs of parallel sides, two pairs of opposite sides that are parallel, and we also have four right angles. So it's a rectangle and a parallelogram. Again, because of those two pairs of opposite sides that are parallel. Now, if we look at our triangles up at the top here, we kind of already talked about it, but triangle V is the only triangle with a right angle. So that one is going to be the triangle that we used to create that quadrilateral. Looking at 11, we want to notice that we have, it looks like two acute triangles, okay? Because all of our angles inside here are less than 90 degrees. And then we also might take our protractor or our ruler and we would learn that these side lengths are the same. So if the side lengths are the same, but this base is not the same, we have two sides that are equal length, which means that we have an isosceles triangle. So we could write acute and isosceles. O-C-E-L-E-S. Oops. Then if these two side lengths are the same, this triangle here is the same triangle, right? We're using triangles twice to create a quadrilateral. So if these two side lengths are the same, these two side lengths must be the same, which means that all four of our sides are the same length, meaning that we have a parallelogram with our two pairs of opposite sides that are parallel, and we have a rhombus. It's a parallelogram and rhombus. Okay. And then we want to look up at our triangles here and decide which one it is. And we know that it's not going to be V, and V in fact is all done because none of our other triangles have any right angles. So we take a look and we see that W has is an isosceles triangle because it has two side lengths that are the same. So we would go triangle W. And we would continue this through 12 through 15. So I'll kind of walk you through and fill in my thought process as we go, but I'm gonna kind of scoot through it because it pretty much matches the same thought process as the first two that we did. So again, we're looking at side lengths and angle measures. So we have an obtuse angle here and here. So I'm gonna write obtuse. It's also a scalene triangle because none of those side lengths are the same. We have a parallelogram. And the triangle that we used twice is triangle Z. We used triangle Z twice to build this quadrilateral. For number 13, we're looking at two obtuse triangles again. So we would put obtuse for our triangle types. Again, a parallelogram. There's nothing really fancy or special about this quadrilateral, just that it has two opposite sides that are parallel. So parallelogram. And if we look at our angle measures and our side lengths, there's only one triangle that has an obtuse angle, and that is triangle Z. So we would put that here. I put my line through so you know it's not a 2. Number 14, this one is kind of tricky. My book and I disagree on the side lengths of the triangle. I'm going to tell you, we're using triangle X for this one. And when I measured it, it looked to me like on triangle X, these two were, if not the same, they were so close I couldn't tell the difference between the two. So I would say those two side lengths are the same. So given that information, I know that it's an acute, that is an acute triangle. It's also an isosceles triangle, that's important to know. Let's spell it right. Isosceles triangle. We've created a parallelogram. And again, we'll have to measure just to be sure, but our side lengths should all be the same, which means that it would be a rhombus as well. And again, we're using triangle X. So if you're not sure, you can double check and measure. These two could be incorrect based on your side length measures. So just use your best judgment and measure for yourself. 15, we look at the side lengths and all of those side lengths are the same. So we give them each one little tick mark. So it is triangle Y that we're working with. It is an equilateral triangle. And the shape that we get is a parallelogram. And a rhombus. So moving on to number 16 through 19, we're going to be very careful in drawing these triangles, and I was much more careful in my book than I will be on my iPad, just because it's a little bit harder to draw lines exactly the way that we want. But when you're doing this on your own, you need to make sure that you're following the directions exactly as it goes, or you're not going to get quite the right answer. So we're going to draw a scalene triangle for ABC. A scalene triangle means that there are no sides that are equal. So We can draw a short side, a super long side, and then connect them here. None of those sides are equal. Okay, what is true about the sides of your triangle? None of them are equal. None of them have the same length. So no equal sides. Oh, I need to name my triangle. A, B, C. Now it says draw a segment from one vertex so that it is perpendicular to the opposite side. Label the segment and mark the right angles. So I'm going to take my segment from vertex B, and I'm going to name this D. And then I have a right angle here and a right angle there. So remember, in order for it to be perpendicular, you need to create right angles. You don't really need anything for that line there. Number 18 says name the triangles formed. So we have triangle ABD and triangle CBD. Okay, and both of these triangles, the only thing that's super special about them is that they are right triangles. So we would put right triangle and again, right triangle. Are the triangles you formed the same size and shape? So, I mean, we can very clearly see that they are not, because we started off with a triangle that had no equal sides. So our triangles are not going to have the same size and shape. There's just no way. So we would say no. Now, for 20 through 23, we're going to use an isosceles triangle. And that means that two of our side lengths will be equal, and only two of them. So again, mine is not going to be perfect because I'm not using my ruler, but yours should be pretty close. This might even be an equilateral triangle, but work with me here. Okay, you know what? I'm going to actually fix these two. There, that I think is better. So these two should be the same length, roughly. Okay, so what is true about our sides is that two sides are the same length. Okay, and then if we look at 21, draw a segment from, oh, I didn't label my J, K, L, there. We're going to draw a line segment just like we did for number 16. So I'm just going to bring that right down here. And then it's really, really obvious that this line is not the same. There, that's better. Okay, so then I should have two right triangles. And again, nothing really to write for 21. So we're going to use this triangle that we've drawn for the next couple questions. So just make sure that you go back to it. So 22, it says name the segments formed, and I need to add one here. Name the segments formed by the perpendicular segment in triangle JKL. What is true about the line segments? So we're talking line segment LM. So I would do line segment LM and line segment MK. And we can say that those two line segments, they should be equal. So we're going to put two tick marks here, because if I put one, then I would be saying that they would be equal to those the sides of the triangle, and that just wouldn't be true. So we're looking to say that the line segment LM and line segment MK are equivalent. They are the same. So we could say they are equal. Or they are half, it's important to notice that they are half of line segment LK. Okay, half of line segment LK. Okay. Name the triangles formed. Are they the same size and shape? So we have triangle JLM and triangle JMK. JMK. And are they the same size and shape? They should be, because we had these two that were equivalent sides, and then we created two sides that were equal as well. So they should be the same size and shape. Now, Puzzled Penguin. He says, "Dear math students, I tried to do exercises 20 through 23 again using an equilateral triangle PQR. I found that line segment PS, so this one, and line segment RS that I formed are not each half of the length of side line segment PR." So he wants it to be half of that. "And the new triangles are not the same size and shape. What did I do wrong?" So his big mistake here is that he didn't make sure that this line segment QS was perpendicular. So if he wanted to correct that mistake, all he would need to do is make sure that his line segment was perpendicular to the to line segment PR. Then he would have half, and his triangles would be the same size and shape. So please let me know if you have any questions. We are nearing the end of our geometry unit, so that's exciting, but continue to work and make sure that you are answering all of your questions on your homework page. I'll see you soon.